Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student about inverse functions. Inverse functions come up primarily in Algebra 2, but then they're used again in calculus, in pre-calculus, and in calculus, although not a lot more in pre-calculus. Okay, the first thing they're testing up here is an XY table. So this is an XY table for f of x, the original. And you can see the table looks like that. Right? You've got the x and the y value is here. So the points would be 1, 0, 2, 2, 3, 3, 4, 6, 5, 4, 6, 1. Well, the coordinates of the inverse would just be you just flip everything. So I'm just going to take the last couple. So instead of 4 and 6, it would just be 6 and 4. This would be f inverse here of x, and then this would be x itself. And you can see I'm just flipping them. 4 and 6 becomes 6 and 4, 5 and 4 becomes 4 and 5, and 6 and 1 becomes 1 and 6. That's just the way inverses work. Hopefully this is the way you were taught in school. So to find the coordinates of the point on f inverse, you just flip the x and y coordinates for f, the original function. So we're going to come over here and do this problem. This is going to be f of f inverse of 6. And this is a composite function. So we just carry the outer function, which is just f, and evaluate f inverse of 6. Well, you can see when x is 6, f inverse is 4. So this is going to be f of 4. And now if you want to evaluate f of 4, you come back here and you can see that f of 4 is equal to 6. And that's the way to do the first one. The second one, we have f of x is equal to 6x cubed plus 5, and we want f inverse. So what we do is we rewrite this. We just say y equals 6x cubed plus 5. Now we switch the x and the y here, so it becomes x equals 6y cubed plus 5. That's what I call the big swap. We swap the x and the y. Now we're going to solve for y. So x minus 5 equals 6y cubed. And then x minus 5 over 6 equals y cubed. And then the last step would be the cube root of x minus 5 over 6. And that's equal to y. But instead of writing y, we're just going to write f inverse here. So that's the way you find the inverse algebraically. We couldn't use this method up top because we didn't have an expression for the function. We didn't have an equation for the function. Right? But here we're given the expression 6x cubed plus 5, and we can use that to find an expression for the inverse, okay, and which is what they're asking for here in this line. And then this one would be the same. You would just say y equals 1 over x plus 3. Then you do the big swap, x equals 1 over y plus 3, and subtract 3, x minus 3 equals 1 over y. And then you can think of this as x minus 3 over 1. Okay, and now we're just going to take the reciprocal of both sides. So, or if you want, you can cross multiply. Let's cross multiply. So you're going to get y times x minus 3 equals 1. And now divide by x minus 3, so y is equal to 1 over x minus 3, like that. And this, of course, is f inverse of x. So that's the way to find f inverse for this function f. And as I said, f inverses are used a lot in Algebra 2 and quite a bit in pre-calculus. And you will see them in calculus, but they're not as big a deal there. So it's worth making the investment in Algebra 2 when you're still in Algebra 2 to learn how to deal with these. Okay, so that's it for this problem. I'll see you again next time. Bye-bye.